I'm going to start with another shout out to our sponsors because this makes it possible to do this. So thank you, Maze, in particular this time, for being a bronze sponsor. And then we're going to immediately start this session with a talk about source IP spoofing in cloud logs. And it's going to be a hands-on look across AWS, Azure, and GCP. And for that, we have Eliav Livneh. Take it away. Thank you.
Hi, everyone, and thanks for joining my talk. Take a look at this screenshot I took of CloudTrail logs. Do you see anything strange? And this screenshot I took of Azure logs. And this screenshot I took of GCP audit logs. And no, I do not own an IP address 1337 from this ISP in China. This is a tale of my obsession with a defensive agent technique that allows attackers to spoof the source IP address with which their actions appear in the victim's logs. So today, we're going to talk about how I originally discovered this technique in AWS, the 3 different cloud provider components that together make this technique, and what happened when I tried to copy-paste this technique from AWS to Azure and GCP. And finally, also, I'll give some suggestions on how you can detect and prevent this in your own organizations. I'm Eliav Livneh. I'm a security researcher at Token Security. And when I'm not doing security research, I'm busy being a dad, riding my bike, or hunting for interesting rocks and minerals in the wild. So the story begins in 2021. I was new to the cloud. It was my 2nd year of learning about AWS. And I was investigating some customers' CloudTrail logs, when suddenly I saw something interesting. I saw an event whose source IP address was an internal IP address. And at that time, I didn't understand what that meant or how that could be. Luckily, the event had a field that quickly pointed me to the fact that this was an API call done through something called VPC endpoint. So what are VPC endpoints? Regularly, the easiest way to make an API call to AWS from within a VPC is to put an instance behind, say, a NAT gateway, or to give an instance directly a public IP address and make the call through the internet. Now, what is logged in CloudTrail in this scenario is the public IP address of either the NAT gateway or the instance. But what if I don't want my instance to have any sort of public IP internet access whatsoever? So here's where VPC endpoints come into play. I can create a VPC endpoint in my VPC, and then make the API calls through it, and it just routes the request through internal AWS backbone infrastructure without ever reaching the internet, which is really cool for security and cost and operations functionality. Now, there is no public IP address to log here, so what does CloudTrail log in the source IP field? Well, it logs the private IP address of the resource that made the call, because that's what it can do. Now, here, we discover the first component that makes the source IP spoofing technique, which is making API calls from within a VPC without them ever leaving to the internet. OK, cool. So now I understood how I saw this internal IP address in the CloudTrail logs. So I wanted to find that resource in that customer's environment that had that IP address to see what resource it was that made it. So I searched for all current and past resources, but I couldn't find any. And that got me thinking, and then I realized that the only reasonable explanation was that this resource wasn't actually in the target environment I was investigating, rather in a third-party environment. So say a third party had legitimate access, say by assuming a role in the target environment, then they would take those credentials from the target environment to their own environment, to an instance they own, and make a call with it through a VPC endpoint in their VPC. What would be logged in the target's CloudTrail is actually the internal IP address of their instance in the third-party environment. And here we discover the second component that makes the technique, which is making, using an identity from one tenant from within the network of another tenant. Now, at this point, I think to myself, OK, cool. But if third parties can do it, then attackers can too, right? If an attacker somehow has access to some sort of credential from a victim, they could make calls from their own environment and control the source IP address that appears in the logs to be any private IP address whatsoever. So this was the first ability for kind of like spoofing the IP that I found. But it was very limited because I could only pick internal IPs, which, I don't know, isn't that strong. It's nice, but it isn't that strong. But then I told myself, I wish I could really have full control over the IP to pick any IP whatsoever. So I thought and checked, wait a moment, what are actually considered valid private IP addresses in AWS VPCs? And the documentation clearly says, we recommend that you use what are generally considered private IP addresses as your private IP addresses. However, you can use any publicly routable IP address as your private IPs. In fact, the only IPs you can't use are these 4 subnets, but pretty much anything else just works. And here we gain the third and last component of this technique, being able to completely control the private IP addresses of an environment that you own as the private IP addresses of your resources. And these 3 make the technique together. So let's see how it works. I created a VPC with this internal IP range 1337 and gave this specific instance this specific IP address as its private IP address, and created a VPC endpoint in the attacker account. And then I created another victim account, and took an access key from it, put it on the attacker VM, made a call through the VPC endpoint, and bam, it worked. This was really cool. I posted about it at the time, 4 years ago, a blog post, and I even referenced it for a minute and a half in a separate CloudTrail logging internals talk I gave it for CloudSec at the time, and I thought it was really neat. Fast forward to present day. I'm still researching unrelated things in the cloud when suddenly I realize, how come I never checked Azure and GCP? This technique is, I don't know, it seems theoretically generalizable and should work on them as well, I thought. So I set out to make a quick experiment because I really wanted to test it on them. But I had one problem. I had very little experience at this point with Azure and no experience whatsoever in GCP. So what do I do if I want to test a relatively complicated networks use case in cloud environments that I know pretty much nothing about? You guessed it. Vibe researching. So I asked ChatGPT to give me just a list of commands to set up this scenario, which I generally described to it. And I just powered through, run through all the commands it gave me. When I got an error, I gave it the error and run whatever command it gave me back without really understanding what I'm doing, just powering through until I could actually reach the conclusion I wanted. So for Azure, I set up some tenant and a VM and a something private endpoint something and a storage account and a service principal and lots of things I didn't really understand. And I made the call with the service principal from the private endpoint thing, and it worked. And GCP as well. I set up a project and an organization and a private service connect endpoint thingy and a bucket and a service account. And it worked as well. I was really happy. Like, OK, yes, this technique works, right? All I have to do now is like write it up, disclose it, send some CFPs, and ride off into the sunset. Well, the thing is, just like vibe coding, when you're vibe researching and don't really understand the things that you're doing, then at some point, things start breaking down. And that's what happened when I started writing this up more thoroughly for disclosure, for reporting, and for an actual write-up. Now, to understand why things broke down and why things didn't work exactly as they did in what I just showed you, let's take a look back at the 2 different environments I vibe researched with ChatGPT and look at the 3 components we have and which one I tested and which one I didn't. So the customizable private IPs, I checked, and by the way, this is not going to be a problem anymore for the rest of the talk. Just all clouds allow this. It's a basic feature, it turns out. Making calls from within a VPC without them going out to the internet, yep, I used some features, it worked. But I actually didn't check cross-tenant. I didn't realize it at the time. When I started writing it up, I realized I didn't test it properly with cross-tenant, so I started doing that. I didn't realize, though, how impactful it is for this technique. And now we'll go into each one of the clouds and go through the process I learned to actually, OK, now I need to seriously learn these concepts I'm dealing with and the features I'm using to try and reproduce it. So let's start with Azure. So the main thing we have to understand is how can we make cross-tenant API calls, but make them through the VPC without them going out to the internet. So there are two features that stood out immediately, service endpoints and private endpoints. Though very quickly, I discovered that service endpoints generally do not allow cross-tenant calls, so that leaves us with private endpoints. Now, private endpoints are something that you have to create to a specific resource. And here is a big difference, whether that target resource is in the same tenant you're creating it in, or in another tenant, which is the scenario we actually want. And as you remember, I tested previously same tenant. But it turns out that when it's a cross-tenant private endpoint, then you need approval from the target tenant to approve your private endpoint request. So this actually already makes it much less feasible for an attacker to do because they need some sort of approval from the target. Let's still continue nonetheless to see where we can get. And some scenarios, this might still somehow be possible, supply chain attacks or trusted third party that might have a private endpoint to the victim somehow regardless. Now, private endpoints you create to a target resource. So it's either in the data plane or the control plane. The data plane is very straightforward. You can create a private endpoint to a specific storage account or key vault, et cetera. But those operations are generally not logged by default. So I was more interested in the control plane, making actual API calls for role assignments and things like that. But the control plane is not a resource. So to get around this, Microsoft created, and probably for other reasons, created a special kind of resource called Resource Management Private Link, which from now on I will refer to as RMPL. So I set out to make this happen, this exact scenario in which I set up an attacker tenant, and in it I want to create a private endpoint to a RMPL resource that exists in the victim tenant, through which I will be able to make API calls to the victim tenant to, say, for example, change role assignments. Now, as I said earlier, I have to do it with approval. So from the attacker tenant, I create a private endpoint, and then in the victim tenant, this appeared, and I had to press and click approve. But when I pressed approve, something happened, and this is completely unrelated now to the source IP spoofing part. I got this error in the victim tenant, which pretty much says, you failed to create this private endpoint because you gave me an access token from the wrong issuer. You used the issuer victim, the tenant you're working in. You should give me an access token from the attacker tenant to make this call, just some approval API call in the victim, which didn't really make sense to me because, right, I would expect the tenant to accept access tokens from the tenant's issuer, not another third party or attacker tenant. So I tried to naively exploit this by making the same exact call, but supplying an access token that I issued from the attacker tenant, but it failed. Probably a separate check in the backend prevented it from working. Now, I'm not good at all at exploiting these types of things, so I stopped here. And I disclosed it to Microsoft, expecting them to also fix the security issue and fix the bug that prevents just cross-tenant RMPLPs from working, because it just didn't work because of this bug. They were able to reproduce it quickly, but surprisingly, they told me that they don't see it as a security concern because it's only a misalignment of issuer validation. OK. They closed the issue. This is still open. If anyone wants to take a shot at it, you might find some more interesting vulnerability than I was from here. Anyway, back to our previous line of thought. So we can't use RMPLs, so let's try something more simpler. In the data plane, storage accounts. So I tried to set up a private endpoint to a storage account in the victim tenant. And then I succeed in creating this cross-tenant private endpoint. I had to prove it in the victim, and then I take a service principal credential from the victim, make the call through it from the VM in the attacker tenant. And the call worked, and it was logged like this. It did work. And not only did it work, there was absolutely no indication in the log that this happened in this flow. No indication that it happened through a private endpoint or that it happened from a different tenant. No information about the original tenant as well. So basically, it just looked like a legit call made from the internet from this IP 1337. So I also wrote this up to Microsoft. so this technique works in Azure, and albeit the cross-tenant does require victim approval for the private endpoint, so that limits very much how much an attacker can actually use this technique, but it does work. So I wrote it up to Microsoft and waited and waited and waited, but after almost 4 months, they did reply back, and happily, they agreed with me that this is a problem, and that they will be addressing this in the future, which is great. I wasn't able to get, as of yet, any estimation for when this will be fixed, or what the log fields they will add to address this, or if that will be the addressing, but this is great. So how can you detect and prevent this in Azure? So because as of yet, there is no indication whatsoever that this technique is being used when it is being used in the logs, the most you can do is audit any cross-tenant private endpoints you have incoming to your tenant and verify that they make sense to you at the very minimum. After Microsoft publishes a fix, hopefully we'll be able to actually audit this in the events themselves. And on the prevention side, also not much, but you can make approval of private endpoints a sensitive action in your environment and limit it to only specific people. OK, so this was Azure. By the way, side note, I checked. This trick doesn't bypass firewalls. Azure network security groups are private endpoint aware, even if it doesn't appear in the logs, but they are aware of it. So this doesn't work to bypass IP-specific rules. So OK, that was Azure. Now let's look at GCP. In GCP, the situation is much, much simpler, because the main feature we have for making API calls that are cross-tenant from within a VPC is called something called private Google access. And let's see how it's used. So generally, private Google access is just literally a checkbox you can enable on any subnet. And when you do, any API calls done in that subnet from resources that only have internal IP addresses, like the scenario we have here, just are automatically routed to GCP's internal network backbone infrastructure, which is really convenient. So I set it up, victim organization, service account credentials, took them to a VM in the attacker organization in a subnet, which I enabled private Google access for, and made a call. And the IP that appeared in the logs was GC internal IP. This surprised me. I didn't expect it. I expected to see the spoofed IP address. I tried different network configurations, and it all had the same results. So I searched this string in Google, and there were only 20 results. But the top one was GCP documentation, which really explicitly does say that if a caller is a VM that only has an internal IP address, and it is from a different organization than the identity being used, then they redact the source IP to simply GCE internal IP. So we see that in GCP, this technique also pretty much works, but you can't really control the IP that appears in the logs. You can only hide it. Now, a note, also in this case, there's absolutely no indication what organization it was done from. Not the organization, not the project, not the VPC, not the instance. All you know is that it happened from a different organization than the identity being used, which I think makes it very hard to detect. So I wrote about it to Google, which replied quickly, but unfortunately, they decided that it's not a security bug, because it would require an attacker to have access to victim credentials, and their documentation clearly advises users to safeguard those keys from compromise. I politely asked if they are aware of a tactic called defense evasion, to which they replied, no, not a problem. It's fine. And about my suggestion to log these additional fields that can indicate when it happens, they told me, why don't you open a feature request? So I did. You can imagine what happened with it since. Nothing. So if you work with GCP and feel like this might impact you, go ahead and +1 it. Maybe collectively we'll be able to cause GCP to do something about this. So how can you detect and prevent this right now? The most you can do for detection is just rely on the GC internal IP and try to see if there's anything unexpected there. But you will pretty much have to stop there, because there's not much information you can do beyond that. And on the prevention side, I didn't test this, but There's something limited you might be able to do with VPC service controls, but this is not a full solution either. Now, back to AWS, I decided to take a look at what changed since I originally founded Technique 4 years ago. And happily, here the situation is the best, because they added in CloudTrail a new field called VPC Endpoint Account ID, and 2 new global IAM condition keys called VPC Account and VPC Org ID, which allow both detecting this and preventing this in a pretty nice way, more than the other clouds at least. So in the detection side, you can detect when calls are being done through VPC endpoints, and then detect public IPs in those same logs, which is very strange, or just unknown account IDs that you are unaware of making calls. And on the prevention side, I didn't test this either, but these keys are new from 3 weeks ago. This is really cool. You theoretically might be able to set up an entire SCP over your entire organization, just denying any calls that happen through VPC endpoints from accounts or organizations that you do not put in a specific allow list that you trust. So to summarize, in AWS, the technique works very well. You can control any IP and use pretty much any target service you want. But there are very strong controls you can use from the defending side to detect and prevent this. In Azure, it's very hard to get it set up for an attacker because you need approval from the victim. But if you do, then currently it's nearly impossible to detect it actually happening, and it's also hard to prevent it. And in GCP, the technique is also pretty strong. You can't control any IP, but you can very easily hide where you're coming from. And it's also pretty challenging to detect it effectively or prevent it. In the future, I'd like to take a look at other clouds, because I didn't yet get to, and look at IPv6, because there's a whole, just using IPv6 is a defensive agent technique in my perspective. And the 3 main takeaways you should take from this talk: don't trust the source IP field blindly in logs. I think I've shown that in the talk. You should always utilize all the log fields you have as much as you can for detecting and investigating when using cloud logs. And finally, clouds are built differently. Copy-pasting knowledge from one to the other doesn't necessarily work that way, so don't make my mistakes. If you're moving to a different cloud to do something, then take the time to learn the concepts thoroughly before you do so. This is far from comprehensive. If you have any suggestions or thoughts or anything I got wrong, or if you're using this technique yourself or if you've seen it in the wild, please reach out to me. The top QR code is my LinkedIn. I'd really be happy to hear anything. Thanks for listening.
Thank you very much. I'm going to kick it off with one of my questions, and then we're going to move it to the room. So if you could pick one of the options, either making the setting this up cross-tenant very hard, or having the detection like it's in CloudTrail right now, like which one would you prefer?
If I understand it correctly, their question, I think cross-tenant access should be a core feature that should be allowed. So I think enabling defenders to be able to detect and prevent this thoroughly, like AWS is doing in a wonderful direction, I think that's most reasonable because it balances the best between operational features and security.
Awesome. Any questions from the room?
Hi. You mentioned that in GCP there is this obfuscation if the tenant is from our organization. And you said you probably wanted to see some other information in there. But wouldn't that also serve as a reconnaissance technique for attacker if it was available?
In what way would it be reconnaissance? Sorry.
If an attacker managed to send you or your service credentials and ask to make a request from your resource, like GCS bucket, for example, they would see in their own log your private IPs and basically could detect what's your layout of the infrastructure in your tenants. So, in my opinion, like if you allow this better data for like against defense evasion, you would actually open up another gate for reconnaissance techniques.
So that's a great question and a great point. I think there's a balance to be made here between how easy it is to defend and how easy it is to protect privacy of organizations here, which is why I think, for example, there should be IDs, but not necessarily strings that make clear what organization it's from. But I think that if you are using credentials belonging to some organization, it's only fair, in my point of view, that that organization has logging of where it happened from. And if you're doing it from GCP, I think that it should at least show which organization ID it happened from. And maybe also the IPs, but at least something to work with.
Okay, thank you very much. Give him another round of applause.